Welcome to the project demonstration of wide speed range electrical vehicle driven system using solar powered BLDC motor and SEPIC converter. So here we achieving the wide range speed control of electrical vehicle BLDC motor. So we are using this 12 volts BLDC motor which is 7 ampere current rating one, and to control this we are using the SEPIC converter, so which will provide us a 3-phase output. So this is the DC to 3-phase converter, as we are using the 3-phase BLDC motor, the brushless DC motor. For that, in order to maintain the constant current and without any noise generation 3-phase output, we are making use of this SEPIC converter, so which will take DC input and provide us the constant current voltage to this SEPIC converters. Both combination is called as SEPIC converter here. So the main application of this SEPIC converter is which will act as a buck boost converter, but the buck boost converter will provide us the inverting output with low stability and low efficiency. So but coming to the SEPIC converter, which will provide us the same polarity based output with high stability, and whenever we are controlling the DC motor applications, the BLDC or normal DC motor, it will provide us the back EMF. So in order to the noise will be filtered, so that will be done with the same polarity based converters. So for that we need to use SEPIC converter or the CUC converter. So this SEPIC converter is mainly application with a low voltage with high current ratings. We are using that input will be getting from the microcontroller signals, and by measuring the input from this potentiometer. If you want to control the speed of this so-called BLDC motor, with the help of this potentiometer we are providing the analog voltage to this PIC 16F72 microcontroller. Based on the input signal, the system will control the voltage regulations to this BLDC motor through this SEPIC converter along with the inverting circuits. And the main components we are using is solar powered, so which is of 12 volts 5 watts DC outputs. So that is input to this battery pack, which is using of 3 4 volt 1.5 ampere rating batteries which are connected in series. So we will get 12 volt 1.5 ampere outputs that can be recharged to the solar panel, and whenever the sunlight is not available we can charge a battery from this transformer. So the both charging circuits are used to convert AC to DC, and from there to unidirectional current flow diodes, and from there to the battery. So here we are using DC solar panel, but there we can see the 4 batteries which will converted using to AC to DC conversion. But in this DC input, these 4 diodes will act as a polarity corrector. Means if we connect the solar panel in reverse polarity, then these 4 diodes will rectify that and provide us the plus to plus, minus to minus. Then we can provide protect the battery from reverse polarity correction. And same, these 4 diodes are used to used for the unidirectional current flow, and the LED indication will show the status of the charger. So as we are using the low lighting on the solar panel, that's why we are getting the low intensity from this LED indication. And after that, once the battery is fully charged in a duration, so either from the solar panel or the transformer, it will get 6 to 8 hours to be fully charged, and after that then only we can utilize the project. The first step is keep the battery under full charge. Then using this on off switch we can provide the power supply to the circuitry, and this is the LM2596 voltage regulator which will provide us the high current rating regulation, as the operating voltage of our microcontroller is 5 volts, and we are going to regulate the 12 volts DC to 5 volts DC with the help of this LM2596 variable voltage regulator. Once we provide the 5 volts input, it start reading input from this potentiometer, and based on the signal from the potentiometer it will regulate the inputs to this inverter from this SEPIC converter. So we are using the SEPIC converter with inverting circuits. So let us see the demonstration. Right, once the beeps completed, the system got initialized, then we can provide the input to this BLDC motor. So smoothly we can control that without any noise and without any restart to the system. The main application of these BLDC motors is low noise and high power can be generated from these motors, hub motors and the BLDC motors. Right.